Okay, so now we're in Chapter 7, and I'm just getting my stuff set up, so I'll be ready in just a second. So the first problem in Chapter 7 is 7.2, is problem 2. So what it asks for is, it says set up the definite integral that gives the area of the region. They don't actually ask you to solve it, but we'll go ahead and do that. So we have two curves. We have a straight line and we have a parabola. And the straight line is above the parabola. So the function we will subtract is f of x, and the one we'll subtract it from is g of x. Now the question is, where are those points of intersection? We have 2 points of intersection, so you can kind of read it off the graph, but it doesn't seem like, it looks like 2, 9 would be one side, and it would be negative 2, 1, but you know, that could be slightly off, but I'm pretty sure. So what we do is we would set the two equations to equations equal to each other, and then we would solve for the values of x which satisfy this equation. And you can see we're going to end up with a quadratic equation because we have an x squared term. So what we do is we would subtract 2x from both sides. So we would get x squared plus 0x, because we have 2x on both sides. And then we would subtract 4 from both sides. So we get negative 4, and that would give us equal to 0. So when you factor that, you get x plus 2 and x minus 2 equals 0. So when x equals negative 2 and when x equals 2, that goes to 0. So those are the x points of intersection. So the corresponding y values, we would say, it doesn't matter which equation you use them, so we might as well use the easier one, which is g of x. So g of negative 2 is going to be 2 times negative 2 plus 5, which is negative 4, plus 5, which is 1, which is what we thought it was, and g of 2 we think is 9, so 2 times 2 plus 4 plus 5 is going to be 9, because it will be 4 plus 5 is equal to 9. So it is, those are the points. So let's put 2 pages up here. So the integral, the area, is going to be the integral from x equals negative 2 to x equals positive 2 of the quantity, which is the upper curve, which is 2x plus 5, minus the lower curve, which is x squared plus 2x plus 1, and both of those multiplied by dx. Now, if we did it the other way around, we would get a negative area. So if you make the wrong choice, you can always realize it by when you get a negative area. So let's go ahead and do this calculation. So we have the integral from negative 2 to 2. So what we'll get is negative x squared from here. Negative 2x plus 2x is 0. And then we get 5 minus 1, which is 4. Whole thing times dx. So we can go ahead and integrate. The integral of negative x squared would be negative x cubed over 3. The integral of 4 is 4x. We evaluate that integration because it's a definite integral. We integrate from the limits from negative 2 to positive 2. So we'll plug the numbers in. So we have negative, the upper limit is 2, so we have positive 2 squared minus 3. Let me put this in the parentheses. Plus 4 times the upper limit. So that's the function evaluated at the upper limit, and then we're going to evaluate it at the lower limit. This part's going to cancel out because we're going to have plus and minus numbers. So, but anyway, we subtract it, and you have negative, the quantity negative 2 cubed over 3 plus 4 times negative 2. Okay, so what we're going to have plus 8, but then you have a negative times. Well, does that actually? I don't think it does cancel out, does it? No, it doesn't. Okay, so the area equals. Okay, so what this is going to be is 2. I forgot to cube it, didn't I? 2 cubed, which is 8, negative sign. So we get negative 8/3 plus 8. And then negative 2 cubed is negative 8 times the negative sign is positive 8 times the negative sign is negative 8. So we get negative 8/3. And then we have negative 2 times 4, which is negative 8. Negative 8 times negative 1 is positive 8. So let me go to add another page. So the 8 plus 8 is 16 minus 8, negative 8 minus 8 is negative 16. So we get negative 16/3. And we find a common denominator, which is 3. So you take 3 times 16, which is 48. So we get 48/3 minus 16/3. 48 minus 16 is 32. So the area should be 32/3. Again, they didn't ask us to do that, but I think that's correct. I think I'll actually, yeah, I'm going to check it. So we're going to do another one of those. 4. So which curve, oh, they show you f of x is the upper curve, g of x is the lower curve. The point goes from 0, 0 to 1, 0. So the area is going to be the integral from 0 to 1 of x squared, the upper curve, minus x cubed, which is the lower curve, times dx. Okay, let's go ahead and calculate it. So the integral of x squared is x cubed over 3. The integral of x cubed is x to the 4th over 4. We're going to evaluate that between x equals 0 and x equals 1, which in this case, the 0 part's easy because they go to 0. So all you really have is the upper limit. So you have 1 cubed over 3 minus 1 cubed over 1 to the 4th over 4. So that's 1/3 minus 1/4. And so what's the answer? Well, I'm going to show you another technique here. If you do this kind of cross multiplication, if you have two fractions, you take 4 times 1, so you have 4 times 1 is 4, minus 3 times 1, divided by the product of these two, which would be 12. 4 minus 3 is 1, so it's 1/12, and that would be the area of that curve. You know, if it had been 1/4 minus 1/3, then you would subtract. You would have 1 times 3, this would be 3, and then you'd have 4, so you'd have 3 minus 4, which would give you a negative 1/12. Okay, we're doing problem 13. And 13 is asking you to integrate two ways, one with respect to x, one with respect to y. And I've worked out the problem because I made an error which I had a hard time finding. So I decided that I would just make sure I didn't mess anything up here. So I've recorded, you know, I'm going to pull these curtains down as I go along. So these are the two curves you can see in the book. You've got this curve, which is x equals 4 minus y squared. And the red line, in terms of x, is x minus y, x is equal to y minus 2. What you see written up there, so these are the two functions. And if we integrate with respect to y, then we're going to use these functions. If we integrate with respect to x, we have to solve these two equations for y. So to do that, you would subtract 2y from both, y squared from both sides, subtract x, and you get y squared is equal to 4 minus x. And to solve explicitly for y, take the square root. And when you take the square root, you get a plus or minus the square root of 4 minus x. The upper part is plus the square root of 4 minus x, and this is negative the square root of 4 minus x, and that gives you the whole curve. It's not a function because it would fail the vertical line test. The red curve this is in terms of x as a function of y here. This is y as a function of x. So you would add 2 to both sides, and you would get x plus 2. So when you integrate with respect to x, which is what we normally do, you'd see that we go from having this as being the top function, which is the line, and this being the lower function, which is the curve, to this part where the upper part is the plus the square root of 4 minus x, and this is minus the square root of 4 minus x. And each one of those is a function, positive the square root and negative the square root. But it's two separate functions. Okay, that's all I have to say about that. So when you integrate with respect to x, you would end up with this integral. So how does that happen? Well, you would go from x equals negative 5 here to x equals 0. That's the point where you change the situation. So we integrate from negative 5 to 0. The upper curve is y equals x plus 2. The lower curve is this curve, which is negative the square root of 4 minus x. So that's the area right here. To get this area on the right-hand side, you integrate from x equals 0 to x equals 4. The upper curve is y equals positive the square root of 4 minus x, and the lower curve is negative. So you subtract the lower curve, and the curve is negative the square root of 4 minus x dx. So that's the integration. The book just says, the answer is, but there's a lot more to it than that. Okay, I'm just going to clean it up a little bit before we integrate it. So this becomes x plus 2 plus the square root of 4 minus x. And here you have positive the square root, and here you have negative times the negative, which is also positive. So you add both of those together, and you get 2. So 1 plus 1 is 2. 2 times the square root of 4 minus x dx. So now we integrate. So the integral of x is x squared over 2. The integral of 2 is 2 dx. 2x, sorry. The integral of the square root of 4 minus x, okay, this is going to be this to the 1/2 power. So when you integrate it, you add 1 to the exponent. You divide by the new exponent. The negative 1 comes from the fact that if you did u substitution, it would be u would be 4 minus x. So du would be negative dx. So when you make the substitution for dx, it'll be negative du. So when you integrate it and stick it back in, that's where the getting the negative sign is, from that part. And you integrate between negative 5 and 0. This is your lower limit, this is your upper limit. The second part is this integral. And it's the same thing, square root of 4 minus x, except you've got a 2. So you get 2 times 4 minus x to the 3/2 times negative 1 divided by 3/2. And you integrate from 0 to 4. So let's plug the numbers in. So when you apply the upper limit, those two go to 0. The only thing you have left is this one. You'll have 4 minus 0, which is 4. So we get the negative sign, which comes from here. 4, which is that, to the 3/2, multiplied by the reciprocal, so you get multiplied by 2/3. Okay, then we subtract the function evaluated at the lower limit. So we subtract, so that goes along with the fact we're the lower limit, the quantity. We get negative 5 squared plus 2 times negative 5 plus 4 times negative of a negative 5 to the 3 halves over 3 halves, which is the same as multiplying by 2/3. Okay, so here it is. Here's the negative signs from the lower limit. Negative 5 squared over 2 plus 2 times negative 5. The last one, you get the negative 1 from here, the negative sign. 4 minus a minus 5. Negative and negative is a positive, so that becomes positive 9. So you'll end up getting 9 to the 3 halves times 2/3 from this thing, reciprocal. Multiplying the same place you got this 2/3 from. First time I forgot this part. Got carried away. So now I have the second integral. 2, the negative sign comes from there. So you get negative 2. 4 minus, well, at the upper limit, you have 4 minus 4, which is 0. So the upper limit goes to, makes this go to 0. The lower limit, you have 0. So you have 4 minus 0, which is 4, to the 3 halves. The negative sign, where have I got that extra negative sign in there? Seems like I've got too many here. Oh no, the negative sign here doesn't come from there. It comes from the fact that I'm subtracting the lower limit. Okay, so this negative sign comes from the lower limit. This comes from there. Ultimately, they'll cancel out. You get the 3 halves reciprocal. So you get 2/3. Okay, so that's it. Now, just to explain, 4 to the 3 halves power. 4 to the 3 halves is the same as 4 to the 1/2 cubed. 4 to the 1/2 is the square root. So you get square root of 4 cubed. Square root of 4 is 2. 2 cubed is 8. So 4 to the 3 halves is 8. Same way, 9 here, square root of 9 is 3. 9 cubed. 3 cubed is 27. So we'll either get 8 or 27. So when we plug all this stuff in, this becomes 8 2/3 minus 5 squared is 25 divided by 2. 2 times negative 5 is negative 10. Here we get 20. This whole thing here becomes 27. So you get negative 27 times 2/3. So that's that. And then the last one, you get, this is 8. Same reason this was 8. So you get 8 times 2, which is 16, times 2, which is 32. So that's where the 32 comes from. The negative times the negative is a positive. Divide by 3. Eight times 2 is 16. 2 times 27 is 54. Then we do is we change them all to 6. So we multiply this by 2, this by 3, this by 6, this by 2, this by 2. So you get negative 32/6 minus the quantity, 75/6 minus 66 minus 108/6 plus 32/3. (32/3) becomes 64/6. So we get negative 32 minus 75 plus 60. Negative times a negative is positive. Negative times negative is a positive 108/6 plus 64/6. So you add all those numbers together, you get 125/6. And that's the correct answer. Okay, so that was part A. Part B is you integrate with respect to y. In that case, you just have one integral. The upper curve is 4 minus y squared. X is equal to 4 minus y squared. The lower curve is the linear part. So you subtract off the x is equal to y minus 2. So you have subtract y minus 2. You integrate with respect to y. If you go back to the original curve, the y limits are from negative 2 to positive 3. So the limits are from, well, actually it's from negative 3 to positive 2. If you look at that, I did it wrong. So let's go back again since I did that wrong. This is negative 3. That's positive 2 right there. Okay, simplify that. You got negative y squared minus y. 4 plus 2 is 6. So that's what we're integrating from negative 3 to 2. So we integrate. The integral of y squared, negative y squared is negative y cubed over 3. The integral of negative y is negative y squared over 2. The integral of 6 is 6y. And then we evaluated the upper and lower limits. There we go. Okay, 2 goes in there. 2 cubed, 2 squared, 6 times 2. Negative, negative, positive. We subtract the lower limit. So we have negative 3 cubed, negative 3 squared, negative 3 times 6. So you can just see that plug 2 and negative 3, subtract the lower limit. So what do we get? 8 cubed is 3 cubed, 2 cubed is 8, negative 8. 2 squared is 4 times negative 1, negative 4 halves. 6 times 2 is 12. Here we have a negative. Let's go from here. Negative 3 cubed is negative 27. Negative 27 becomes positive 27 times negative is negative 27. So we get negative 27 thirds. Negative 3 squared is positive 9. Positive 9, negative 9, positive 9. Positive 9 halves. 6 times negative 3 is negative 18. Negative times positive is negative times negative is positive. So you get that. Now we convert them all to 6. Multiply this by 2, this by 3, this by 6. Because this, if you multiply by 2, you'll get 6 here. You multiply by 3, you'll get 6 there. Multiply by 6, you'll get 6. So this becomes 16, this becomes 12, this becomes 72. 16, 12, 72. The second part, multiply by 2, 54. Multiply by 3, 27. Multiply by 6, 108. You add all those together, you get 125. So you get 125.6, which is the same answer. So anyway, that's it. Okay, next couple of problems. It says sketch the region bounded by the graphs of the algebraic functions and find the area of the regions. So I want you to use the graphing program to plot these out. So you get y is equal to 1/2 x cubed plus 2. So that's a cubic function. Y is equal to x plus 1. From x equals 0 to x equals 2. So let us go to the graphing program. Check, check. Okay. So here we are. So we have 1/2 times x cubed plus 2 colon x plus 1, y equals x plus 1. And let's just show from 0 to 2. So we'll put x equals 0 for a minimum and x equals 2 for max. So there it is. So this is the area between these two. Which one is, this is the lower curve, which is a straight line. This is the upper curve. Let's just zoom out a little bit. So that's what it looks like if you look at it in more detail. What we're going to do is we're going to go between 0 and 2, which is right here. That's the area. So the thing we need to remember is that the linear part is the one we want to subtract. So we set up the integral. So the area is equal to the integral from x equals 0 to x equals 2 of the upper curve, which is the cubic function, minus the lower function, which is the linear function, all multiplied by dx. So we're integrating with respect to x. So what we need to do is just simplify as much as we can. So we have 2 minus a minus 1, which is 2 plus 1. So we get 1 half x cubed minus x plus 3, the whole thing times dx. And since that's just a polynomial, pretty straightforward, you get 1 half x to the 4th over 4 minus x squared over 2 plus 3x, evaluated between 0 and 2. At 0, everything goes to 0, so all we have to do is evaluate it at the upper limit. So we get 1 half 2 to the 4th power divided by 4 minus 2 squared divided by 2 plus 3 times 2 minus 0, basically. Okay, 8. This is going to be 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 divided by 4 is 4. 4 divided by 2 is 2. Here we have 2 squared, which is 4. 4 divided by 2 is 2, so we have negative 2. And then we have plus 6. So the area should be equal to 6. So let me just check the book. Okay, that's not what the book says. What did I do wrong? Oh, okay, that should be plus. That is, so then I have minus 2 minus 1, so that becomes positive 1. So that becomes just x. And that becomes x. Just plus 1 times x. So then we have plus 2 there. So that becomes plus 2. And that's the correct answer. Problem number 20. So this is also, again, finding the area between two curves. So we have two curves. F of x is equal to negative x squared plus 4x plus 1. G of x is equal to x plus 1. Now this is going to be a curve that's like an upside down U because of the negative sign. And this is going to be a straight line, so probably this will be the lower one. This makes sense. But we'll confirm it by plotting these functions. And they don't give any limits, so that assumes that the point of intersection is going to be the limits. So what do we have? We have negative x squared plus 4x plus 1 colon x plus 1 graph. So there it is. And, you know, it looks pretty obvious what the x values are. It's going to be x equals 0 and x equals 3. We could confirm that. Let's just confirm it. So x equals 0 and x equals 3. Write that down. X equals 0, x equals 3. Yeah, I'm not sure why I stopped the recording there. Okay, so here we go. We're supposed to prove analytically. So we set the two equations equal to each other. Find out the values where they are equal to each other. So what I'm going to do is I'm going to, well, let's just subtract x and 1. So we get negative x squared. Subtract 1, you get plus 3x. And subtract 1 from that, and you get 0. So you factor out x, you get x times negative x plus 3 is equal to 0. So x is equal to 0 and x is equal to 3. So that's what we already knew by looking at the graph. So what we can do is we can set the integral. So the area is the integral from x equals 0 to x equals 3 of, the upper function is the polynomial, and the lower function is the line. Before we integrate, let's combine like terms. So we have negative x squared. We have 4x minus x. So we have plus 3x. And we have x plus 1 minus 1. So actually ends up being what we got over here. Okay, so now we integrate. So we get negative x cubed over 3 plus 3x squared over 2 from x equals 0 to x equals 3. Again, because they're polynomials, this lower limit is going to go to 0, so all we have to do is evaluate this at the upper limit. So we have negative the quantity 3 cubed over 3 plus 3 times 3 squared divided by 2. So this is going to be 27, so it's going to be negative 27 thirds plus 3 times 3 is 9 times 3 is 27, so 27 halves. And if we put it in terms of 6, we need to multiply this by 2, so we have negative 54 6, and we have to multiply this by 3 to get 6 in the denominator. So that 3 times 27 is 81. So the answer is 81 minus 54, which is how much? Well, it's going to be 6. You get to 60 plus 10 is 70, so that's 16, 26, one more, 27, 27, 6. But you can divide both of those by 3, so you would get 9 halves. And that's correct. Yay! Try to find my cursor here. '21. So we have it's very similar to 20. So we have x squared plus 2x plus 1, which is going to be a parabola pointing upward. We have g of x is equal to 3x plus 3. Okay, so let's plot this again, just like we have been doing. So that was the last function that we were dealing with. 21 is x squared plus 2x plus 1, and we have 3x plus 3. So there it is. Let's zoom out a little bit. So it looks like x is in -1 and x is equal to 2. And the linear curve is on top in this case. Okay. Now let's confirm it again. X squared plus 2x plus 1 is equal to 3x plus 3. Subtract 3x, get negative x. 2x minus 3x is negative 1x. And then we get negative 2. 1 minus 3 is 2. We factor that. We get x minus 2, x plus 1. So that when you multiply that, we get a negative x. So the limits are from x equals -1 to x equals +2. So those are limits of integration, which is, I think, what we just said, but I'm going to just check it out. -1, +2. Okay, great. So now we integrate. The area is the integral from -1 to 2. The upper curve in this case is the line, and the lower curve is the parabola. So we'll get the integral from -1 to 2 of -x² from here. We got 3x minus 2x, which is plus x. And then we have 3 minus 1, which is plus 2, which is the negative of that thing right there. But so the integral of x² is x³ over 3. The integral of x is x² over 2. The integral of 2 is 2x. We evaluate that between -1 and 2. Unfortunately, it doesn't go from 0, so we got to evaluate two integrals. So we have -2 cubed over 3 plus 2 squared over 2 plus 2 times 2, and then we subtract, evaluate it at the lower limit, which we have -1 cubed over 3 plus -1 squared over 2 plus 2 times -1. So the first term becomes -8 thirds. The second term becomes plus 4 halves plus 4. So that's the first three terms. Second three terms is we'll have -1 cubed, which is -1, times -1 is +1, times -1 is -1. So we get -1 third. 1 squared, -1 squared is +1. +1 times negative is -1. So we get -1 half. And then we have -2 times negative, so that becomes +2. 4 halves, just as this is 2. So, and then let's combine all this stuff. So we get -9 thirds. -8 minus a third is -9. We get 2, 4, 6, 8. Plus 8 minus 1/2. So again, well, this is 3. So we get -3 plus 8 minus 1/2. So that's equal to 5 minus 1/2, which is 4 1/2, which is 9 halves. So I get 9 halves if I did it correctly, which is correct. Problem 27. So 27 is different because it's a function of y instead of a function of x, which makes it a little harder to plot. So what we're going to do is I'm going to rewrite it as a function of x so we can at least look at it and then use it using our regular graphing program. So f of y is x. X is equal to y squared, and x is equal to y plus 2. You know, we're used to having y equals something, but so let's go ahead and do it. So what is y? Y is going to equal plus or minus the square root of x. We take the square root of both sides. And y is going to be equal to x minus 2. So we subtract 2 from both sides. Look at y is equal to x minus 2. So those are the functions. So let's go ahead and plot those. So what do we have? We have plus or minus the square root of x. So we'll have the square root of x negative the square root of x, and x plus something. I forgot what it was. Plus 2, I think. X minus 2. Is that right? X minus 2. So we graph that. So that's what it looks like. So this is x equals y squared, or y equals plus or minus the square root of x. So we have two curves that we have to do that because this thing will only plot functions, and the function has to satisfy the vertical line test, which this composite thing does not. So what we can see is if we do it with respect to y, this is going to be the upper curve, and this will be the lower curve. If we did it the other way, we'd have to break it up into two parts, where this was the upper curve to here, and this is the lower curve to there, and then we would have this the upper curve, and this the lower curve. So that would be if we had integrated with respect to x instead of y. Okay, so let me actually just copy that into our presentation. Okay, so we're going to go back to the whiteboard. So there's our thing. So the area is going to be the integral, and the limits are in the y direction. Normally we'd have the limits in the x direction, but because we're integrating with respect to y, so we have this is the maximum y value where they intersect, which would be y equals 2, so that's the upper limit. The lower limit would be down here, where we have the intersection of the blue curve and the green curve, which is -1. So we're going to integrate from y equals -1 to y equals +2. Again, our upper curve is this one, which is the linear part. So we have y plus 2. And we subtract the lower part, which is y squared. And we multiply by dy in this case. So that's the integral, and the rest of it's exactly like what we've done before. It's just we're using y instead of x. So before we integrate, I'm going to remove the parentheses, and I'll rewrite it as y squared minus y squared plus y plus 2 times dy. So this should be pretty easy, except when we get to the part where we got to deal with all the fractions things. So the integral of -y squared would be -y cubed over 3. The integral of y would be y squared over 2, and the integral of 2 is 2y. And we evaluate that between y equals -1 and y equals 2. So what that means is we plug this into each term and then subtract plugging that into that term. So let me just add another page. So the area is going to be equal to -2 cubed over 3 plus 2 squared over 2 plus 2 times 2. So that's the first part. And then we subtract the lower limit. So that's -1 cubed divided by 3 plus -1 squared divided by 2 plus 2 times -1. So let's go ahead and just multiply everything out first. 2 cubed is 8, so we get -8/3. We get a positive. 2 squared is 4. 4 divided by 2 is 2. Then we have plus 2 times 2, which is 4. So that's the first part. And then we subtract off the second part. So we have -1 cubed, which is -1 times -1 is +1 times -1 is -1. So we get -1 times a negative, positive. So that's going to be +1/3. Here we have -1 squared, which is +1. So we get +1/2. And then we have 2 times -1, which is -2. Okay, I'm going to remove the parentheses. And let's go ahead and add those two together. So we get 2 plus 4 is 6. Then we'll have the negative sign. So we have -1/3 minus 1/2 plus 2. Let's go ahead and combine all the terms that are similar first. So you get negative 8 minus 1 is negative 9. So it's negative 9/3 plus 6 minus 1/2 plus 2. So let's go ahead and change that 6 into an 8. And so we can actually, the 9/3 becomes 3. So we get negative 3 plus 8 minus 1/2. That's equal to 8 minus 3 is 5. 5 minus 1/2. That's the same as 10/2. 5 is 10/2 by multiplying the numerator and the denominator by 2, subtracting 1/2, and I get 9/2 as the answer. So let me just check the book. It's 27, section 7.1. Almost there. 9/2. Yeah, it's funny, 9/2 ends up popping up a lot for some strange reason. But okay, so that's correct. Problem 35. So we're only going to do parts A and B of this one, which is use the graphing utility and find the area. So really it's not that much different than the previous ones, as far as we're concerned. So let me write the equations down first. 35. So it's y as a function of x. And what we have is two quadratic equations, one that points up and one that points down. And there's going to be a point of intersection, which we might be able to deduce from the curve, but we'll do it analytically as well. So I think that's what it is. 35. Okay. So I'm just going to plot these two functions. So what do we have? We have y equals x squared minus 4x plus 3 and 3 plus 4x minus x squared. So you can see we have a plus x squared and a minus x squared. So as I advertised, one's going up, one's going down. So you can see they intersect here at 0 and at 4. But we'll prove that analytically. So the one pointing down is the one that's going to be on. We're going to subtract this one from that one. Let's go ahead and do it like we did last time. We're going to didn't want to do that. Oh, heck. Okay, just have to let it happen and then delete it. I was in the wrong place when I pushed the button. Okay, now we'll go back over here. That little thing, go there. I don't know what happened to my picture. Let's try it again. Okay, there we go. So we're going to find the area between those two curves. Okay, first thing we were going to do was to find the intersection. So what we do is we set them equal to each other. X squared minus 4x plus 3 is equal to 3 plus 4x minus x squared. So if we want to move everything over to the other side and get 0 on the right hand side. So we're going to add x squared, so we get 2x squared. And we're going to subtract 4, so we'll get negative 8x x, and we're going to subtract 3, which will give us 0. So simplifies like that. And we can divide out a 2, so we divide everything by 2. Then we factor out an x, so we get x times the quantity x minus 4 is equal to 0. So the 2 points of intersection are x equals 0 and x equals positive 4, which is what we already knew. Okay, so now let's set up the integral. I'm going to copy this over to a new page. And we said the one pointing downward was the one that is the greater one over that integral. So we're going to integrate. The area is going to be equal to the integral from 0 to 4 of the upper curve, which is 3 plus 4x minus x squared. And we'll subtract off the other one, which is x squared minus 4x plus 3. And we multiply by dx, so we can integrate. Okay, let's combine like terms before we integrate. You wouldn't necessarily have to, but you have less terms if you do that. So you have negative 3 minus 3 is 0. So we get 4x minus a minus 4x, so that's positive 4x. We get 8x. And then negative x squared minus x squared is going to be negative 2x squared. And we don't divide by 2 in this case. We have to keep them because we're not finding the zeros. We're just trying to find the area. Okay, so the integral is going to be equal to 8x squared over 2. So the integral of x is x squared over 2. Then we have 2 times x cubed over 3. And we evaluate that between x equals 0 and x equals 4. When we plug in 0, we get 0. So all we have to do is evaluate it at the upper limit. So we get 8 times 4 squared divided by 2 minus 2 times 2 cubed divided by 3. So 8 divided by 2 is 4. So this becomes 4. So we have 4 times 4 times 4. And that 4 cubed is, well, 4 squared is 16. So 4 times 16 is 64. So we get 64 halves minus, and then we have, oh, I see, I don't want to put a 2 in there. That's 4. So okay, hopefully this number's less. Okay, so we get 64 checking things out here. Oh, I don't know why I did that. I knew something was wrong because I was going to get a negative number. This should be 64. So 4 times 4 times 4 is 64. I put the 2 in there for some reason. I don't know why I did that. Okay, so you get 4 cubed, which is 64, times 2, which is 128. So we get 128 thirds. So let's find a common denominator, which is 3. So 64 times 3, get my calculator out, 64 times 3 is 192. So you get 192 thirds minus 128 thirds. So when I subtract 128 from 192, I get 64. 64 thirds, which you can't divide 64 by 3. So that's the simplest form. And this is number 35. 64 thirds. Okay. '43. So it's the sketch the region bounded by the graphs of the function, find the area. So nothing new except we're doing trig functions here. So let me write them down. So 43. F of x is equal to 2 times the sine of x, and g of x is equal to the tangent of x, and we're looking between the intervals of negative pi over 3 and positive pi over 3. So let's go graph those. And let's put the limits in here so we just see what we need to see. Negative pi divided by 3. I think that's the way to do it. Let's go to help and find out. I always forget. Pi. I guess we just put pi in. Okay. Negative pi divided by 3. The upper limit is positive pi divided by 3. Now the function, one function is 2 sine of x, and the second function is tangent of x. So there we are. So what you can see is that there's this symmetry. I'm going to zoom in the y direction just so you can see a little better. So you can see there's a symmetry in the y direction. This one's above and this one's below, and then it flips around. So the best thing to do is to take the integral from 0 to pi over 3 and double it. So sometimes you can do that. You could also break it up into 2 parts, but you'd have to do, you know, this would be the upper curve and this would be the lower curve for one of them, and then it would flip around. So I would say just we'll do the integral from 0 to pi over 3 and double it. And the question was, which one was above? So let me go back here and look at the graph. So the red curve, which is the first function, sine, is above. So, okay. So that'll be the one we put first. So the area is going to be equal to 2 times the integral from 0 to pi over 3 of the sine, 2 times the sine of x, 2 sine of x minus tangent of x dx. Okay, so let's do it. So we have 2 times 2 times the integral of the sine, which is going to be negative the cosine. And the integral of the tangent is, well, I forget exactly, it's a natural log of something. We'll go to page 383, I think it is. Yeah, 383. The integral of the tangent is equal to negative the natural log of the absolute value of the cosine of x. And we evaluate that between 0 and pi over 3. So we get 2 times 2 negative the cosine of pi over 3. I'm going to do these separately. So then we'll subtract 2 times negative the cosine of 0. So that's this term evaluated, the upper limit, subtracted the lower limit. Then we have minus, and we'll have negative the natural log of the absolute value of the cosine of pi over 3 minus the natural log of the absolute value of the cosine of 0. Close parentheses. The cosine of pi over 3, if you go back to the unit circle like this, the sine of theta is equal to y. Cosine of theta is equal to x. So what it's saying is that we're looking at pi over 3, which is right here. So it's pi over 3. And it's going to be the sine, which is this, the vertical displacement at the point, is going to be closer to 1. Here it's about right in the middle. So from that we can say the cosine of pi over 3 is equal to 1/2. And we can also say the cosine of 0 is the x-coordinate here for the 0 angle, which would be 1. So the cosine of 0 is 1. So we get 2 times negative 1/2 minus 2 times negative 1. And then we subtract minus the natural log of cosine of pi over 2, which is the natural log of 1/2, minus the natural log of the absolute value 1. And I think the book just leaves it in terms of natural logs. So let me just check the answer here. Yeah, pretty much. So let's go here. So let's see, I saw the answer has the natural log of 2 in there somehow or another. Not sure what it is. No. Yeah, I think it's because it's, okay, I understand. They always leave out a lot of steps. So we have 2 times negative 1. 2 times negative 1/2 is negative 1. Then we have negative 2 times negative 1, which is positive 2. This part, we've got a negative times a negative, which is a positive. So that becomes positive the natural log of the absolute value 1/2. And we can take the absolute value sign off because we don't need it. And then we have the natural log of 1 is 0, so that goes to 0. Okay, so then we have, so we still have the 2 out front here. 2 minus 1 is 1, plus the natural log of 1/2. Now, it turns out if I do this, so if I go 2 times 1 minus a minus the natural log of 1/2, so you get 2 times 1 minus, well, the negative sign, you can take that inside it's negative 1 inside, so that becomes the natural log of 1/2 to the minus 1 power. And so 1/2 to the negative 1 power is you basically take the reciprocal of that. So that becomes negative the natural log of 2. And if you carry out the calculations in your calculator, you get 0.614 approximately. Yeah. I can't think of any other, I mean, that's the correct answer. It just seems funny that they would, this is an acceptable answer, why they decided to do that. I guess it's a little cleaner because it has a whole number instead of a fraction. But they leave out a lot of stuff there, so. Okay, the last problem is another trig problem. So we get 2 functions. F of x is equal to the secant of pi x over 4 tangent of pi x over 4. G of x is equal to the square root of 2 minus 4 times x plus 4. And we have from x equals 0 to probably where these things intersect. So make sure I copied that down correctly. Okay, so we're going to go and we're going to plot that thing, because I have no idea what that looks like, and you have no idea what it looks like. So you got to plot these things. So the first function is the secant of pi x divided by 4 tangent of pi x divided by 4. Second function is square root of 2 minus 4 times x plus 4. And then we have x equals 0, which is a vertical line. So let's go from x equals 0. And let's go to pi. I'm not sure where this thing actually goes. Okay, didn't like what I did there. So let me see if there's anything. Maybe it's just I need to put the pi, put a little times there or something like that. Pi x. Tangent of pi, oh, x over, I put r. Let's try that. There we go. Okay, so this is the tangent function, I'm pretty sure. I think it's down here. Actually, that's the secant tangent. And this is a linear function. And it actually says, well, yeah, x equals 0. Is that x equals 0 or y equals 0? No, it's x equals 0. Yeah, okay, so let me move this up. So we're actually talking about this area right here. So this is the top curve, this is the bottom of the curve, this is the left-hand side. We go out here to this point of intersection, which looks like x equals 1. But I think we'll prove that it is x equals 1. I mean, it's obviously x equals 1, but let's just prove that by setting the two functions equal to each other and seeing what happens. And we see the linear function is greater. That was another thing we needed to know which function was on top. And I'm going to copy that picture over. So let me do that. So there it is. So what we're looking at is this area right here. Okay, so the first thing I said you could do is find this intersection. I don't know. That looks a little daunting. Yeah, I'm not going to do that now. I may go back and do it, but it's too much of a chance to. So the area is going to be equal to the integral from x equals 0 to x equals 1. The upper curve is square root of 2 minus 4 times x plus 4. So that's that function. We subtract the function below, which is the secant of pi x over 4 tangent of pi x over 4. And then we multiply the whole thing by dx. So we just do the integrations. There's not really much we can do here. So we're going to equal, it's going to be square root of 2 minus 4 x squared divided by 2 plus 4x minus, well, the integral of the secant tangent, if you go back to page 383, you see the integral of the secant tangent is the secant. So what will end up there is the secant of, well, yeah. Let's do that separately. Let me just make a little space here, because it's not just, you have to take into account things. So what we would do is we'd let u equal pi x over 4. So du would be equal to pi over 4 dx. So when you do this integration, which we'll do without the integral sign, without the limits, we'd end up with the secant of u. So that says dx is equal to du times 4 divided by pi. If we solve for dx, so you get secant of u tangent of u times dx, which is du times 4 divided by pi. And when we plug, so that ends up being the secant of u times 4 over pi. So this one's going to be, we'll move that out front, so you get negative 4 over pi times the secant of pi x over 4. Okay. I'm just thinking here, I'm going to evaluate that between 0 and 1. So the 0 for these two goes to 0. So you end up with the first part. For 1, you get the square root of 2 minus 4 times 1/2, 1 squared divided by 2, plus 4 times 1. And then we get minus 4 over pi times the secant of pi times 1 divided by 4, and then we subtract at the lower limit, which is the secant of pi times 0 divided by 4. Okay, so that's now we just have to work everything out. So what is the secant of pi over 4? Well, the secant of pi over 4 is 1 over the cosine of pi over 4. And the cosine of pi over 4 is the square root of 2 over 2. Or 2 divided by the square root of 2, if we multiply this by the square root of 2 over 2, we get 2 times the square root of 2 over 2, so it's equal to the square root of 2. So that's the secant of pi over 4. The secant of 0 is equal to 1 over the cosine of 0, which is equal to 1 over 1, which is 1. And here we get 1, so what we'll get is, so let's plug all this stuff back in. We get the square root of 2 over 2 times 1/2. And then we have negative 4 times 1/2, so that becomes negative 2. Here we get 4 times 1, so we get plus 4. Then we have negative 4 over pi times the secant of pi over 4, which is equal to the square root of 2. And then we have this 4 over pi times the secant of 0, which is 1. Okay, let me just stop here for a second. Make sure I haven't made any mistakes. A lot of opportunities to make mistakes here. Okay, I missed a minus sign here. It's a negative times a negative, so this one becomes a positive. But I think everything else is okay. Just checking all these numbers. Yeah, okay, that's all okay. So I think all you have to do is just simplify it a little bit. So the area is equal to, yeah. Okay, so here we go. This is what the book says. It's the square root of 2 over 2 which is this part. 4 minus 2 is 2, so we get plus 2. We can factor out the 4 over pi, so we get plus 4 over pi, and we have 1 from there, and we have minus the square root of 2 from there. And that's the answer. And the number, if you plug it into your calculator, you get 2.1797. So if you want to watch that again, you are free to. I guess I'm going to go through it just one more time to give you all the details. Okay, so we plotted the curve. We had the blue curve is this curve. We have the red curve, which is that curve. And we have x equals 0, which is the vertical line. So that defined the area. So this is the upper curve, lower curve. These integrals are pretty simple. This one we had to use the u substitution, so we got this 4 over pi part in here, which we may have inadvertently left out. So the integral of minus the secant tangent of this is basically take the reciprocal of the constants that are in here, 4 over pi times the secant, which is the derivative of the secant is the secant tangent. So then we plugged in 1, which gave us this and that. And if we plug in 1, we also get this one. And then we plug in 0. These two go to 0, and then you have the second term. And we subtract it here because it's the lower limit. This is the upper limit of the lower limit. And then we found out what the secant of pi over 4 was. It's 1 over the cosine of pi over 4. The cosine of pi over 4 is the square root of 2 over 2. So you can take the reciprocal of that, which is reciprocal of this, and multiply by 1, so you get 2 divided by the square root of 2. Multiply both of them by the square root of 2. This goes to 2. This cancels out with that 2, and you end up with the square root of 2. The secant of 0 is 1 over the cosine of 0. Cosine of 0 is 1, so you get 1 divided by 1, which is 1. So then you plug them in to this equation. So we got square root of 2 times 1/2 minus 4 times 1/2 plus 4, and then we have the last part, minus 4 over pi, evaluating at the upper limit gives us this. It's negative because the negative's from here, from the original equation, because we're subtracting because that's the lower curve. And so anyway, we found that the secant of pi over 4 was the square root of 2. You get a negative times negative, which gives you positive. So you get 4 over pi times the secant of 0, which is 1. And then all we did was we combined these two terms, and we factored out factored out 4 over pi, so that left us with 1 minus the square root of 2.